So I have two emitters here. One emits heat, one emits fluid, and then look what happens. We have fuel comes from the bottom, it hits, it lights up, and then we have everything lit up. We have reactions. So this container, as you can see, this is 2D container, so it goes much faster. It doesn't have to calculate the depth. The other voxels that's in the depth, it's just flat. So we have density, velocity, dynamic grid, temperature dynamic grid, and fuel dynamic grid. So we'll all have set up. And then the bottom emitter emits fluids, and the top emitter has heat to it. So whenever it reaches one, and there's a reaction, boom. That's example for you to know what does fuel does. It feeds that temperature, the heat. So let's go back. Play every frame, don't forget. Always dynamics, play every frame. All right now we have only density and velocity. We don't have temperature, no fuel. Shading method, all right. Okay, display. Yeah, right now we are in display. When we simulate we can see fuel or temperature. It will show us separate, kind of layers inside the container, what's going on. So if we have a run into problem, we want to see what does temperature do, we can just set it up on temperature. Right now there's no temperature, there's only density. Or as a render, it's like all together. So we can see velocity. You see velocity draw, this thing? It shows us where the voxel, which way they float to. So you see them from the middle, it goes up and it goes around. So those arrows, you can change the length of those arrows, and you can skip them too. So you draw arrowheads, or you have the heads with the direction. That's a boundary draw. You can have outline. You see, that's our cube. But most convenient will be like bottom. Sorry, bottom. So now you see the resolution, and it doesn't disturb you to look inside the cube, the container. Wireframe display. You can do rectangles, and then if you hit wireframe, that's what happens. You can see some little rectangles here. So we'll keep it on. We'll keep it off. No, we'll keep it on particles, and then we'll disable velocity draw. So that's for display. That's just for when you simulate and you see what's going on. Just when you plan and when you build your simulation. Next, dynamic simulation. Here we have gravity. We can disable that. We have viscosity. Like in a particle, same thing. Friction, damp. Add some. Sometimes it's good. Just to slow it down. Make it more natural. Look more natural. Here there's our solvers. I think this one is faster. I think so. But all right, high detail solve off. Sub steps, the same thing like when I was telling you about cache. You can add sub steps. It will take longer to calculate, but you will have more accurate calculations. For example, if you have a meteor flying too fast through your cube, you can add sub steps, so it will calculate per frame. You have more calculation per frame. Solver okay, start frame. Here, start frame, same thing. If you want to start later, you can put 20 or whatever frame you want to start your fluids. But for example, you have reaction and you have something you don't want to simulate yet. Then rate scale, how fast will simulation go? So you can, for example, the blasts go at least twice as fast as normal. Regular, it goes up all the way up to 8, and we have some violent explosion here. So if you go and say, multiply it by 8, see how fast it goes? Boom. If you say 0.5, slow. Can you see that? Okay, here. Very slow. But if you say 16, Boom. That's you tweak it, yeah, when you can open that. Let's see, pirate, what's that? Pyrotechnics, I just blast. Yeah, you can see this container is set to 16. See, rate scale 16. So it goes like if you play blast this thing. Okay. See what happens. Goes fast. Bang. So that's 16 times as you can see, simulation rate. All right. New. Okay, now we have a start frame. Okay. Now next thing. Yeah, you can disable evaluations per container. So if you don't want to, if you want to mess with the animation and you don't want to slow it down, you just click disable evaluation. Nothing happens. It doesn't calculate anything. So click. Don't forget to unclick. Click, unclick. Select, unselect. Auto resize. We already seen what it does. Self attraction. We don't need it for now. Density. Right now we have only density in our container. I think so. Let's see. Yeah, density and velocity set to dynamic grid. So, density scale. Come on, do it faster. All right, density scale. Sorry, I think it's disabled. All right. 600. So density scale, we can tweak it up. That's our density scale. Beyonce. It's if you want to, for example, if you want to go negative, you can do minus. It's the speed with which the fluid floats or sink. In this case, if you give it negative buoyancy, it will sink. Let's say it's sand and water or something, or some heavy ink, it will go down to the bottom. If it's very light, if it's some gas that evaporates quickly and go up, we can say +4. Let's say plus. So it goes up very quick. So I'll keep it 1, for example, here. So that pushes the density up. In this case, where I mean here. So let's keep it 1. Dissipation is how fast the fluid disappears. For example, if you make a steam, look at that heating plant that we have in Hanover. We see the steam comes out and it dissipates. It's not smoke. The particles don't hold. They just become drops of water and then they dissipate. So we add dissipation here to our density, and you see it doesn't even hold. It just go away quickly. Sorry. So let's adjust it, like take 1, and keep in mind those things are quite sensitive. So sometimes it's 1/100th of unit. So be careful about tweaking it. Don't just give it like 1,000 units dissipation, because it's just from 0 to 1. So just add a little bit if you want a little dissipation, if you want some reaction. If it's like steam, just add, 0.3 already will be like serious difference. So what's, okay, put a 0, diffusion. Diffusion is how the particles stir up, how they mix, not particles, voxels. So if we add diffusion, you see it doesn't keep the shape, it goes all around the like container. See what's going on? That's diffusion. And then noise, tension, gradient force, that's for later. So 0. Noise is just some turbulence here. You see we have like some kind of turbulence. We can also control it through other methods. Velocity is it's better to see on the 2D container. Let's give it some more resolution. Let's say 60. Because it doesn't have to, it hasn't. This is 2-dimensional container, so it doesn't have the depth. It only simulates what, 60 by 60. So if we make a cube, it will add 60 times more. So our simulation will be 60 times slower. In this case, we can, like for example, if you have something on the distance, some mushroom cloud on the distance, you can definitely go and use a 2D container. So right now, let's check what does velocity do. So if we crank it up all the way to 10, the swirl, see that? That's what it does. We can add some noise to it. Has more details now. And the turbulence. Turbulence shakes it up like we have in the particles. Remember that turbulence field, see? Just moves it all around, and you can add frequency and the speed. That's our container turbulence. There's all kind of this. Emitter also has turbulence, so there's all different ways to add turbulence. You can also add add field to your fluids as well. So the same fields that work in particles or rigid bodies, they work in fluids as well.